Right, so welcome to lesson 2 of the differential equation, and today we're going to learn about how to obtain the solution to the DE when the DE is variable separable. Okay, so again, if we're going to review, the solution to the DE doesn't contain any differential. Okay, so the differential, as you can recall, is something that has y prime, y double prime. So that's a differential. That's differential. All right. So, so when we say the D is variable separable, this only means that you can separate x from the function of x from the function of y. So the variable separable differential equation follow a certain format structure. So all you need to remember is to follow the structure. Okay, the structure goes like this. So any function that has any function of x must be paired with this one dx plus any function of y any function of y dy is equals to okay is equals to 0. So what this means is the rule is very simple. So pair them. Okay, so arrange a differential equation in a way that all x pairs with dx and all y pairs with dy. Okay, so what does it mean? So let's try an example. So let's say, uh, let's say x squared y dx plus x dy is equals to 0. Okay. So again, using the structure as I mentioned a while ago, all you need to do is to separate x from y. So we pair x with dx and we pair y with dy. So x dx, okay, then y with dy. Alright, so I forgot something. I forgot this one, x. Okay. So you're going to separate it in a way that it will the differential equation will look like exactly like this. So let's try. So x squared. Okay, so the thing that's does not belong here is y. So all you need to do is to put it here somewhere. Now the question is how. So simply divide both sides by y. Okay, so that will cancel out y here. So it's going to be x squared dx plus x over y dy is equals to 0. Now the only thing that missing that remains is the x in the dy part. So you again divide by x. So see that we'll have x dx plus dy over y is equals to 0. Okay, so do we follow the format? Do we follow the format of the structure? Yes, so we already have mx here and we already have ny here. So we already follow the format. Now, that's actually the first step. So the first step is to separate x and y and follow the structure. So we follow the structure, and this is the structure. I call it structure, but it's not really structure. It doesn't really not. It's not really called structure. I just call it structure. Okay. So that's step number 1. Now, oh sorry, where did I delete this one? So that's structure. That's step number 1. What is step number 2? Okay. So step number 2. So after you arranged it, arranged it in a way that it follows the structure, we're going to integrate it. So We're going to integrate x dx plus integrate dy over y is equals to 0. So integrate that also. So if we're going to integrate that one, obviously you're going to have plus c later. Okay, so integrating this section, we have 1/2 x squared plus this one is following the ln. So we have ln. Okay, so again, integral of 0 with respect to whatever it is, but if we x or y, obviously you're going to be resorting to only plus c. Now, sir, do we have? We already know that integrating x dx should be have plus c here somewhere, sir, right? So dapat sir, di ba may plus c? Wala may plus c dito. Um, Actually, yes, but all you need to remember is that if you're going to move plus c and plus c over here, it's going to be the same c. So you don't really have to do that. All you need to do is to follow the structure, to follow the format, and you'll be okay. Okay, you follow the steps. Just follow the steps, and you'll be okay. Okay, so plus c. So what's the next step? What's the next step? So the next step is to, yeah, that's it. I mean, yeah, that's it. Step number 2, integrate. Integrate. And actually, the third step is do not forget to equate to C. Okay? Do not forget to equate to C. So again, this is the first step. You separate the we separate x and y in the differential equation if it's variable separable, okay, and you're going to perform integration, okay, and third step is do not forget to equate to c. Okay, so that's it. Now the question is, sir, what will happen if it's not variable separable, if you cannot separate x from y? Okay, so the quick answer for that is obviously it's not you're not this technique will not work anymore. So that's going to be the next topic, okay, which is homogeneous differential equation. Okay, so before I end, let's try another example. Okay, so another example. So let's try a little bit different. We put y prime, sorry, y prime is equals to, what do I put here? X y squared. Okay, before I end the video, I have to remind you again that this technique I'm teaching you is only applicable for first order differential equation, okay, which means that you will only see one prime, so y prime lang, so hindi na kayo makakita ng mga y double prime because that's already in a higher order differential equation, remember. Okay, more than one is many. Okay, so that's only for FWE. Okay, so if you can remember, y prime is dy over dx. Okay, so we're going to rewrite this in a way like that. So it's going to be dy over dx is equals to x y squared. Now remember, the structure is mx dx plus ny, sorry, ny dy is equals to 0. Okay, now you're going to, the challenge again is step 1. You're going to arrange this in a way that will follow the format or structure. So the only way for you to do this is to, to put dx on the right side. So it's going to be dy is equals to x d, sorry, xy squared dx. Okay, now the trick is this. We're going to do this. So dy, so this is positive, right? So you're going to you're going to move it on the left side. So it's going to be minus x y squared dx is equals to 0. Now, does this already look like it? Well, sir, negative and positive to. Yeah, doesn't really matter, no? Doesn't really matter. So, the trick again is step number 1, separate. Now, what you see here is that we have y squared on the dx part in the x part. So you have to move y squared here on the dy part. So obviously we divide it by y squared. So we have dy over y squared minus x dx is equals to 0. Okay, so continuing here, arrange. So we're going to have positive x dx minus dy over y squared is equals to 0. Okay, so inarrange ko lang. Okay, multiply both sides by negative 1 to make the negative x positive, and then making the positive dy negative, and then obviously 0 to. Okay, so now that we already did the first step, integrate. So that's the second step, integrate. Okay, so integral of this is 1 half x squared. This one, this will not follow the ln. Okay, hindi ln niya na, hindi yan ln y squared. No, we do the you do the power rule. Okay, so the trick is you're going to move y squared upward. So that'll be y negative 2 dy. Okay, so you follow the chain rule. So it's gonna be minus 1 over 1 minus 2 plus 1, then y negative 2 plus 1 is equals to c. Okay, so and 1 negative 1, so will be 1 half x squared plus, so we're going to be y, okay, 1 over 1 minus 2, so we have 1 over minus 1, so it's gonna be negative 1 times negative, so it's positive. So y negative 1 is equals to c. So this is not done yet. Okay, we're going to move negative 1 below because we don't want a negative exponent. So it's going to be 1 half x squared plus 1 over y is equals to c. Okay, so this is the answer. Yay! So madali lang, diba? So madali lang ang variable separable. Now, again, kung hindi mo ma-separate yung x and y, that's already, obviously, that's gonna be the second one, which is homogeneous. And that's gonna be for the next video.